Bismillahirrahmanirrahim. Welcome to the question and answer for the section 1 of the material balance. So let's start with the first question. Okay, for the first question, we are asked to draw the system. We are asked to draw the system diagram and pick a basis and write the degree of freedom for the following. So for the first section A, for the first question, the dehydration of low molecular weight alkenes can be carried out using the ferric oxide catalyst. What are the mass and mole fraction for the cerium and the oxygen? So here is the question. This is the important part of the question. We are asked to find out the mass and mole fraction. So let's first draw the system diagram. The system diagram is very easy. We will put a block to represent the system, and the system is just a catalyst containing cerium and 2 atoms of oxygen. So the second part is to pick a basis. So to pick a basis, we need to know how to answer the question. So for the mole fraction, we need to know the number of mole for the atom and the number of mole for the total number of moles for the mixture. We have and for the mass fraction, we need also to find out the mass for each atom and the total mass for the chemical compound. And to find out the mass, we need to know the mole, and we need to know the moles and the molecular weights. So let's find out the degree of freedom. The degree of freedom is, as we said, it's the number of unknown minus the independent equation. Here we have 4 unknowns. We don't know the molar mass for each component, the cerium and the oxygen, and we don't know the mass for the cerium, also the oxygen. So we have 4 missing unknown. However, from the general chemistry, we can find out the molecular weight from the periodic table. And we can find the chemical reaction. Also, if we find the chemical reaction, we can know what is the moles. And the chemical reaction goes as Ce plus O2 from the general chemistry. Ce O2. This information is from your background in general chemistry, which is prerequisite to this course. So if we know the chemical reaction and we know the molecular weights, we can we have three nouns from the independent equation. So the degree of freedom is 1 because we have 4 unknowns and minus the 3 independent equation that we get from the general chemistry. So the basis is 1 mole, because if we pick a basis as 1 mole of Ce, we can get the number of moles of O2. Then we can get the mole fraction, and also we can transfer from moles to mass, and then we can get the mass fraction. I'm not gonna solve it because the question doesn't ask you to solve it. It just asks you to find out these three things. So I have found it out. So let's move to the other question. You have 90 kilograms of gas containing 40% nitrogen and 30% carbon dioxide and 30% methane in a tank. What is the average molecular weight of the gas? So here is the question. So let's draw the system diagram. Basically, we have a container which contain these components, and we are asked to find out the average molecular weight. So how can we solve this question? We know that the average molecular weight is equals to the sum of molecular weight times its fraction. So for this specific question, it will be by this equation. The mole fraction of N2 times the molecular weight of N2 plus the mole fraction of methane plus the molecular weight of methane plus the mole fraction of carbon dioxide and the molecular weight times the molecular weight of carbon dioxide. So the degree of freedom, basically, we have no unknown. We know all the equation, and also we don't have any independent equation because it's easy to solve. However, for the basis, we need to get a basis to solve this equation. This equation actually gives you 90 kilograms. You can transfer it to moles because moles equals mass times the molecular weight. Moles equal to mass times the molecular weight. But it doesn't matter if we have 1 kilogram or 100 kilogram or 90 kilogram. The molecular weight for the same composition, it will be the same. So it's easier to pick a basis if 1 mole or 100 mole or 1 mole of the gas mixture, and to solve this question, because this question doesn't need the mass or moles. It just requires the mass fraction and molecular weight. And this is the basic idea of basis. You pick a basis that will make you solve the question in an easy way. You can do the mole conversion from mass to mole conversion, but it isn't required, and it's easier to pick a basis of a mole and solve it because the average molecular weight will be the same, and it doesn't matter if the composition is the same, the average molecular weight will be the same, and it doesn't matter the mass or moles. So let's move on. Let's move on to the third part of this question. Chlorine usage at water treatment plant is 134 pound per day. The flow rate of water leaving the plant is 1,050,000 gallons a day. What is the average chlorine concentration in the living water? So let's draw the system. Here is the system basically. 134 pound chlorine per day enter the water treatment. Also unknown flow rate of water enter the water treatment, and we have the outflow rate of 1,050,000 pound gallon chlorine. Here it's a mistake, it's a gallon chlorine per day. So the question is asked you in this part, what is the concentration of chlorine? It's asked you the concentration of chlorine. So we know that the concentration of from the general chemistry, we know that the concentration is equals to the number of mole of the component over the volume of the total solution. So we need to know the number of mole of chlorine, and we need to know the the volume for the outlet flow rate. So the degree of freedom analysis, it's that we don't know the number of moles and we don't know the volume. However, from the general chemistry, we know we can get the number of mole if we have the mass, and if we have the molecular weight, and we know that the density from the general chemistry, we know that density is equals to mass over volume, so we can get the volume. So we have two unknown, but we know two equations, so it would be 0. The symbol we can the basic basis we can use to solve this specific question is to pick a temperature of 100 Celsius, because if we know the temperature, we can get the density of water. I have picked 100 Celsius because we can get the density of water. After we get the density of water, we can get the volume. After we get the volume, we can get the mass, and then we can get the moles, and then we will the mole for chlorine, it's given. We know the mass, we just have to transfer. So we can get the volume from the density, and we just convert the chlorine mass to get the moles. So if we just pick a temperature, we can get the volume, and the question will be solvable. So let's move on to other question. So the second question is asking you to draw the system then state if the system is open or closed, continuous or batch or semi-batch, steady state or unsteady state. We are given 3 systems. So the first system is a block of ice melting by the sun. So let's start with part A. First, let's draw the system. We have a block of ice, and here is the system boundary. I have dashed it with a red line, and when the sun is erecting the rays on it, some of water is evaporating and some of them is melting. So what is the system type? We can see that it's an open system because the materials leave the system. The system is a semi-batch process because materials only leave, there is no material entering. And the system is a steady state system because it's we are assuming that it's a continuous, the leaving of water evaporating and melting is continuous with time. So let's move to part B, clothes being dried inside the dryer machine. So in the dryer machine, you put the clothes. The clothes will be wet with water, and basically there is a heat on the drying machine generated by the electricity, and water is being evaporated when the heat is ejected onto the cloth. So we can see that the system is semi-batch also because there is some material leaving. So the system is open system, and it is a semi-batch process, and it is a steady state system also because the water leaving it's at a continuous rate. So for part C, the inside of an eggshell while it's boiling in a hot water at 100 degrees Celsius. So there is the system. Our system is the eggshell. Our system is the eggshell. Here is the boundary of our system. Realize that I didn't put the water and the whole thing. The boundary. This is the system of. This is the system for our. This is our system because we are analyzing and accounting what is inside the system. The inside of an eggshell. It doesn't matter what is happening outside. We can clearly see that the system is a closed system because the outside of the shell is not getting out or enter into our system. It is a batch process because all the operation is happening inside the system, and there is no materials entering or leaving. It is a steady state system because the temperature is continuous and the operation is continuous inside the system. Okay. For the third question, a mechanic blends oil by mixing 300 kilogram per minute of number 10 oil with 100 kilogram per minute of number 14 oil. The mixer oil is withdrawn at the rate of 350 kilogram, 380 kilogram per minute. How much oil remains in the tank after 1 hour? So here is the question, and it's asked in hour, and all we have and all the mixture we have is in minutes. So here is the system diagram. We have 300 kilogram entering, and we have 100 kilogram per minute entering, and we have 380 kilogram of mixture that contain oil 10 and 14, and we have unknown compositions. But it doesn't matter with us with the question, because the question is just ask how much oil remains in the tank after 1 hour. So we need to know how much oil is in the tank. So we need to know the accumulation. From our general material balance equation, we know that the accumulation is equals to the input minus the output minus the consumption plus the generation. So in this specific example, we don't have any chemical reaction, so there is no consumption and there is no generation. Both of the term will be 0. So we have the accumulation equals to the input, which is 300 plus 400 minus the output. It will be if we do the calculation, it will be 20 kilogram per minute. After that, we just do a simple conversion for the units. We have 20 kilogram per minute, so 1 hour we have to convert from minute to hour. So the minute will go to the minute, and the 60 will be, and it will be 1200 kilogram per hour. For the fourth question, does the following set of equation have a unique solution? And we have this set of equation. To have a unique solution, we know that the number of unknown must equals to the number of equation. In this process, we have 1 and 2 and 3. We have 3 unknown and we have 3 equation. If we just do the degree of freedom analysis, we can see that we have 3 number of unknown, and we have 3 components. We have 3 equations. So we have a unique solution is possible to exist. However, you have to check out if mathematically if the set of 3 equations have a indefinite solution or definite solution. I'm not gonna do it because we just need to understand the degree of freedom analysis, and there is a possible solution for the set of equations. So for the last question, find the degree of freedom for the following system and write how many values are required to be able to solve the system. we have two systems. We have to find the degree of freedom analysis and how many values are required to be able to solve the system. So for this, for the first system, let's analyze the system. We do know x2 and we have x3 unknown. We have for the x2 and x3 composition is unknown for the 10 kilogram. As we said, for this x2, we said the sum of x is equals to 1. So if we know, or if we know x1 and x2, x3, x2 is known. So, and for this one, it's also x3 is known. So here we don't know x1. So here we don't know x2 and x3. If we know one of them, the other part will be known. So the degree of freedom will be that the number of variable minus the number of independent equation. We only have x2 unknown or x3 in the stream 10 kilograms. For the material balance, we have 3 material balance. So the system is the degree of freedom is -2, which means the system is over specified and it can be solved. So let's start with the other system to analyze it. We have for the unknown, we don't know f1, we don't know x1, we don't know x2. However, x3 we can get it because we know x1, and if we know x1 and x2, we know x3. And for part B, we also don't know B and x1 and x2. For the fluoride W, we don't know x1, and if we know x1, we will know x2, and otherwise is also true. So we have for the unknowns, we don't have 8. The sum of the unknown will be 8, and we only have 3 component balance. We have x1, x2, x3. So this for the system degree of freedom analysis, it will be 8 minus 3, so it will be 5. The system needs a specification to be solved. So we need at least 5 extra information of composition or flow rate to solve the system. That was it. It was an easy part. It's just to get you understand what is the meaning of system, and it's just to let you understand the basic ideas.